May of 2022, a message arrived at NASA's Jet Propulsion Laboratory from a machine that had no business still being alive. It came from more than 14 billion miles away. It had taken over 20 hours to cross the void between the spacecraft and Earth, traveling at the speed of light the entire way. And when engineers finally decoded it, the message made no sense at all. Not corrupted. Not empty. Nonsense. Numbers that didn't correspond to anything the spacecraft could physically be doing. A description of its position and orientation that matched no state it could possibly be in. It was as if the machine had started speaking in a language nobody had ever taught it, reporting on a version of itself that didn't exist. And here's the part that unsettled the engineers most. Everything else about the spacecraft looked perfectly fine. It was still collecting data, still pointed at Earth, still, by every other measure, healthy. Only this one system had started transmitting what looked, for all the world, like the ravings of a machine losing its mind. 45 years into a journey nobody expected it to survive this long. The spacecraft was Voyager 1. And this wouldn't be the strangest thing it had done. Not even close. Because 3 years later, in the silence of interstellar space, this same aging probe would do something that made scientists stop and reconsider what they thought they knew about the space between the stars. And when its computer nearly died for good, the fix that brought it back would come from a place no one expected. A memory bank the size of a photograph, and a chip nobody had used since 1981. This is the story of how a machine launched during the Ford administration keeps finding things that shouldn't be there. If you're new here, welcome. We tell stories about the edges of human knowledge, the discoveries that make scientists pause before they speak. Stay with us, because what Voyager 1 detected in the quiet beyond our solar system is still being studied today. And it changes something fundamental about how empty we thought empty space really was. Let's go back to the beginning. In September of 1977, a spacecraft roughly the size of a small car left Earth, on a trajectory that took advantage of a planetary alignment that happens once every 176 years. Jupiter, Saturn, Uranus, and Neptune were arranged in a way that let a single probe visit multiple worlds, using each planet's gravity as a slingshot toward the next. Engineers called it the Grand Tour. Voyager 1 took the inner path, built for speed rather than a full planetary survey, and it flew past Jupiter and Saturn, sending back images that rewrote textbooks. It found volcanoes erupting on a moon called Io. It found evidence that Saturn's moon Titan had a thick, hazy atmosphere unlike anything else in the solar system. Then it did something no one had planned for so soon. It kept going. In 1990, on its way out of the solar system, Voyager 1 turned its camera backward one last time, at the request of Carl Sagan, and took a photograph of Earth from nearly 4 billion miles away. In that image, our entire planet appears as a single pale dot, barely a pixel wide, suspended in a beam of scattered sunlight. Sagan later wrote about that photograph in terms that still circulate today, the idea that everyone who has ever lived did so on that one small point of light. It was a quiet, almost accidental gift from a machine built for engineering purposes, not poetry. And it was only the beginning of what this spacecraft would end up teaching us about our place in the universe. Its mission was designed to last 4 years. It's now been running for almost 50. And somewhere in the 1990s, engineers began to realize that Voyager 1 wasn't just going to outlive its mission. It was going to outlive the very boundary of the solar system itself. That boundary is worth explaining, because it's stranger than most people assume. Our sun doesn't just emit light. It constantly sheds a stream of charged particles called the solar wind. And that wind inflates a kind of bubble around the entire solar system, a bubble called the heliosphere. Imagine blowing into a balloon while standing in a smoky room. The air from your lungs pushes the smoke back and carves out a clear space around you. That's roughly what the sun does to the material drifting between the stars. Inside that bubble, the sun's influence dominates. Outside it, you're in someone else's territory, the vast, ancient material that fills the space between star systems, called the interstellar medium. For decades, scientists debated where exactly that boundary was, and what crossing it would even look like. Then, in August of 2012, Voyager 1's instruments recorded a sudden, dramatic change. The density of particles around the spacecraft jumped by a factor of 40. The direction of the magnetic field shifted. Everything the spacecraft was measuring told the same story. It had left the sun's bubble behind. Voyager 1 had become the first human-made object to enter interstellar space. Take a moment to sit with that. A machine, built with less computing power than a modern key fob, had traveled so far that it left the influence of our star entirely. And it was still working well enough to tell us about it. But leaving the heliosphere didn't mean leaving the mysteries behind. If anything, it was only the beginning. Because interstellar space, it turned out, was not the silent void everyone imagined. In 2017, something happened that first hinted at this. Voyager 1's plasma wave instrument, a piece of equipment designed to detect oscillations in charged gas, picked up a burst of activity. A shockwave, triggered by an eruption from our own sun years earlier, had finally rippled out far enough to rattle the thin gas around the spacecraft. And the instrument recorded it like a seismograph picking up a distant earthquake. That much scientists expected. Solar storms were known to send shockwaves rippling outward, and catching one this far out was already remarkable. But then something else appeared in the data. Something that had no business being there. In between those shockwave events, when everything should have gone quiet, the instrument kept registering something. A faint, steady signal. Not a burst, not an event. A continuous, low murmur that simply never stopped. At first, researchers weren't sure what they were looking at. It was too consistent to be noise from the spacecraft itself, and too persistent to be another shockwave. It just sat there in the data, month after month, like a tone that had always been playing, and no one had been listening closely enough to hear it. It took years of careful analysis before a team led by astronomer Stella Koch-Ocker at Cornell University confirmed what the signal actually was. Published in the journal Nature Astronomy in 2021, the finding was almost unsettling in its simplicity. The thin, nearly empty gas of interstellar space was constantly vibrating on its own, producing a faint drone of plasma waves with no external trigger at all. Here's the analogy that makes it click. Picture a completely empty concert hall. No orchestra, no audience, nothing happening. You'd expect total silence. But instead, if you put a sensitive enough microphone in that hall, you'd hear a low, continuous hum coming from nowhere, in particular the air itself vibrating ever so slightly, all the time, for no obvious reason. That is essentially what Voyager 1 found in the space between the stars. A steady vibration in gas so thin it barely qualifies as matter, humming quietly in the vacuum, whether or not anything dramatic was happening nearby. Researchers on the team described it as something closer to a gentle, persistent rain than an alarming signal background noise from the ordinary jostling of electrons in the interstellar gas, likely stirred by cosmic rays passing through. But the significance wasn't in how dramatic it sounded. It was in what it revealed. Before this discovery, scientists could only measure the density of interstellar plasma when a solar shockwave happened to pass through and rattle it, the way you can only measure water depth when someone throws a stone in. Now, thanks to this constant hum, researchers had a way to monitor the density of the material around Voyager 1 continuously, without waiting for a lucky event. It meant the ancient, tenuous material drifting between star systems had a signature of its own, one that had been sitting there the entire time, waiting for an instrument sensitive enough and patient enough to notice it. Consider why that matters beyond pure curiosity. The heliosphere isn't just a scientific curiosity, it's a shield. It's the reason cosmic rays, the high-energy particles that stream through the galaxy at close to the speed of light, don't reach the inner solar system at full strength. Understanding exactly how that shield behaves, how it presses against the interstellar medium, and how that medium pushes back, matters for anything humanity ever sends farther into space. And for understanding how habitable a solar system needs to be shielded to remain. Every measurement Voyager 1 sends back from beyond that boundary is data no other instrument in history has ever collected. Because no other instrument has ever been out there long enough or far enough to collect it. And the implications reached further than the researchers initially expected. If the interstellar medium hums constantly, on its own, without needing a solar storm to stir it into motion, then the space between star systems is far more dynamic than the empty, frozen picture most people imagine. It suggests turbulence, structure, and subtle activity spread across light years of material that astronomers had largely modeled as static and inert. Every star system, as it turns out, may be sitting inside a quietly restless ocean of ionized gas. One that our own instruments only started listening to for the first time in the early 2020s, using a machine older than the researchers analyzing its data. That alone would have been enough to make Voyager 1's extended mission a landmark in the history of space exploration. But the spacecraft itself was aging in ways that made every one of these discoveries feel increasingly fragile. Which brings us back to that strange, garbled message from May of 2022. For months, the team at JPL worked through the mystery of why Voyager 1's attitude control system was reporting a version of reality that didn't match anything possible. The rest of the spacecraft was healthy. The antenna was still locked onto Earth. The instruments were still gathering science. Only the health reports coming from this one system read like static, dressed up as data. Engineers eventually traced the problem to something almost poetic in its irony. The system responsible for reporting the spacecraft's status had, at some point, started routing its information through an onboard computer that had stopped functioning years earlier. It was, in effect, asking a dead component for directions and getting scrambled nonsense in return. The rest of the spacecraft never noticed, because the dead computer wasn't actually controlling anything, it was just being asked, mistakenly, to relay a report it could no longer produce correctly. The fix, once identified, was almost anticlimactic. Engineers simply commanded the system to route its data through the correct, working computer instead. Within days, the readings returned to normal, but the deeper question why the system had started listening to a dead machine in the first place was never fully solved. It remains, to this day, one of the small, permanent mysteries etched into Voyager 1's 50-year logbook. If that had been the end of it, it would already be a remarkable story. But the real test of this spacecraft's endurance was still ahead. On November 14, 2023, Voyager 1 went quiet in a new and far more serious way. It didn't stop transmitting. The radio link stayed connected, a faint carrier signal still reaching Earth across more than 15 billion miles. But the information riding on that signal had collapsed into something meaningless, a repeating pattern of ones and zeros that carried no actual data at all. Engineers described it later as though the phone line was still open, but the voice on the other end had been replaced by a flat, endless tone. For 5 months, the team worked the problem with almost nothing to go on. Every command sent to the spacecraft took over 22 hours to arrive. Every response took another 22 hours to come back. A single question, an answer, could burn nearly 2 full days. And they had to ask their questions carefully, because Voyager 1's onboard computers, in total, hold less memory than a single photo on a modern phone. There was no room for trial and error. One wrong command risked silencing the spacecraft forever. Finally, in March of 2024, A diagnostic readout gave them what they needed. A single memory chip inside the flight computer, responsible for packaging the spacecraft's data, had failed. It held only a small fraction of the total memory, about 3%, but that fraction happened to contain a piece of code essential to formatting everything the spacecraft tried to send home. There was no way to repair it. No technician was ever going to fly out and replace a chip 15 billion miles from Earth. And there was another wrinkle that made the situation feel almost impossibly tight. This computer had a backup built into the spacecraft from the very beginning, in case exactly this kind of failure happened. But that backup had already failed decades earlier, back in 1981, when Voyager 1 was still relatively new. There was no second chance left, just one working system, with a piece of it now permanently gone. So the engineers did something remarkable. They couldn't restore the missing memory, so instead they rewrote the affected code to work without it. They broke the lost section into smaller pieces, small enough to tuck into scattered fragments of memory still functioning elsewhere in the computer, and rewrote the internal instructions so every piece would know exactly where to find the next one, like a puzzle scattered across different rooms of a house with a note in each room pointing to where the next piece was hidden. Then they sent the first piece of that patch across the solar system, waited nearly 2 full days for it to arrive, and waited again for confirmation. On April 20th, 2024, Voyager 1 sent back its first readable data in 5 months. Somewhere in that message, encoded in the same kind of ones and zeros that had meant nothing for half a year, was proof that a piece of software written for a spacecraft in the 1970s had just been rebuilt, remotely, from across the width of the solar system, by people using tools and techniques that hadn't even been imagined when the original code was written. It's worth pausing here to consider what this spacecraft actually represents. Voyager 1 carries a golden record on its side, a collection of sounds, images, and music intended to describe humanity to whatever, or whoever, might one day find it drifting between the stars. It was assembled by a committee led by astronomer Carl Sagan, a kind of message in a bottle cast into the deepest ocean anyone has ever imagined. And while that record has been silent cargo for nearly 50 years, the spacecraft carrying it has never stopped working, never stopped listening, never stopped finding things nobody expected to find. A machine older than most of the engineers, who now keep it running, detected a sound in the empty space between the stars that scientists didn't know existed. A single dead chip nearly ended one of humanity's longest conversations with the universe. And it was saved not with new hardware, but with ingenuity applied to hardware that predates the personal computer. Voyager 1 is still out there right now, moving away from us at about 38,000 miles per hour, its plutonium power source fading a little more every year. Scientists have already had to shut down several of its instruments permanently to conserve what little power remains, and within the next several years, they expect to have to power down instrument after instrument until, sometime around the end of this decade, the spacecraft will likely go silent for good. But, even then, it won't stop moving. It will keep traveling, carrying its golden record for longer than human civilization has existed. Longer, quite possibly, than our species will exist in its current form. It will drift past stars that don't yet have names assigned to them by anyone alive today. A silent artifact of a species that once looked outward and decided to send something of itself into the dark. There is no successor waiting to take its place, not really. Newer spacecraft, like the New Horizons probe that flew past Pluto, are also heading toward interstellar space, but none of them carry the same instruments, the same history, or the same 40-plus years of continuous data that make Voyager 1 irreplaceable. When its transmitter finally falls silent, humanity will lose its only working set of eyes and ears in the space between the stars, and there are no firm plans yet for another mission built specifically to listen there again. Whatever Voyager 1 hasn't told us by the time it goes quiet may stay untold for decades, until some future generation decides it's worth building another messenger and sending it out to follow the same long, dark road. That's part of what makes every signal it still sends home feel less like routine telemetry and more like something closer to a final testimony, one data packet at a time. What Voyager 1 has taught us, again and again, across 5 decades, is that the universe rarely runs out of surprises, even in the places we assume are the emptiest and the quietest. A hum in supposedly silent gas. A computer reporting on a version of itself that didn't exist. A dead chip and a rescue built out of nothing but patience and code. Each of these moments, on their own, might seem like a technical footnote. Together, they tell the story of how much we still don't know about the space just beyond our doorstep, and how far human curiosity is willing to travel to go find out. Somewhere out past the edge of what our sun can touch, a machine built by people who could never have imagined the world we live in today is still listening to the universe, and still, somehow, finding its voice. If this story made you think differently about how much is still unknown, even in the emptiest corners of space, let us know in the comments what part surprised you most. And if you want to keep exploring the edges of what we understand, there's another story waiting for you right here.